So we're on cosine rule. We use cosine rule if we are given a triangle. Maybe if you are given triangle so let's call it maybe triangle A, B, C. You know the sides C. This is small letter B and this small letter A. As when you are given, formally, we are given two sides and an included angle. And we're asked to find the third side. That's the side opposite the given angle. So the rule states that the square of the unknown side equals the sum of the squares of the known minus 2 times the product of the known side. Okay, the known side is BA, cosine of the known angle. So that's what cosine rule states. So if you are given two sides and an included angle, to get the third side, that's the one opposite that angle, that's what it states. So let me just do a quick proof on that. So assuming we form a right triangle with it. So assuming this angle 90, so let's call here, from here to here, x. So let's call here h. So formally we added h and x, but what we are given is a, b, c. So whatever that we're going to get is in terms of a, b, and c. So you notice that from triangle, this right angle triangle A, okay, let's call this D. Triangle A, D, C. You see that x squared plus h squared will give us b squared. That's Pythagorean theorem. So that's our equation 1. So again, in that same triangle ADC, we know that here, okay, let's call here theta. Let's call this, you know, C, cos C. Okay, let's call theta as C. So we know that here, the angle here is 180 minus theta. So you now see that in that same triangle ADC, that cos 180 minus theta, that's SOHCAHTOA. Cos is adjacent over hypotenuse. So our adjacent is x, so x over b. So which implies that if you make x the subject of formula, x is now b cos 180 minus theta. But you know 180 minus theta means second quadrant, and cos is negative, so we can write cos 180 minus theta as minus cos theta. So we have minus b cos theta. That's from trigonometry. 180 minus theta is cos 180 minus theta is minus cos theta. So again, in triangle ADB, that's the bigger triangle, right triangle ADB, you see that apply Pythagorean theorem again. You see that x plus a all squared plus h squared will give us 6 squared. So expanding this bracket, we see that is x squared. Expanding this, we have x squared plus a squared plus 2ax plus h squared equals c squared. So we now replace x for this x here with minus b cos theta, while I replace h squared with b squared minus, you know, making x squared the subject of formula is now b squared minus x squared. So I have x squared plus a squared plus 2a. So x, replacing x with this, we have minus b cos theta plus h squared. I was making h squared the subject of formula here is b squared minus x squared equal to c squared. So you now see that x squared minus x squared is 0. So we have a squared plus b squared. We open up this, now minus 2ab cos theta equals c squared. So we have x squared, a squared plus b squared minus 2ab cos c equals c squared. So with this now, making cos c the subject of formula. So generally, again, we can still use cosine rule if you are given all the three sides. So making cos c the subject of formula, you see that cos c will now be a squared plus b squared minus c squared over 2ab. Make cos a the subject of formula, you still have b squared plus c squared minus a squared over 2bc. And finally, if you make cos b the subject of formula, you still have a squared plus c squared minus b squared over 2ac. So we use cosine rule if you are given sides, or if you are given two sides and an included angle.